Hey everyone, welcome to this webinar hosted by UReason. I've started a minute early. I'm just waiting for some more of the attendees to come in. There's already quite a group there. Welcome. So with us today are three moderators. We have Carlos, Arthur, and Florian, who will be moderating the webinar. If you have any questions, any issues, etc., use the chat. You can reach out to them and ask them questions as well. They're all moderators with a technical background, using our software, working for our customers on a day-to-day basis. And so they are quite well equipped to answer your questions. Don't hesitate if you have questions during the webinar. I will wait for a minute or so, and then I shall start the webinar. Starting the webinar means that the camera image that I'm currently sharing will disappear, and there will be first some slides, and after the slides a live demonstration of digital twins on a process loop, which is quite interesting and shows you some of the capabilities, some of the advantages also of using and utilizing digital twins. So I'll just wait for a minute before starting. And I'm going to switch the camera image off. I'll be back. Well, I won't disappear, of course, but I'll be back for the Q&A session with the camera image showing instead of slides and content on my machine. Okay, I'm going to share screen now and start with the webinar. Again, welcome everyone to this webinar hosted by UReason. In this webinar, I will explain what digital twins are and how you can apply digital twins in the world of data-driven maintenance. The webinar consists of 4 parts. First, I will briefly introduce the company, UReason. After this, I will go into detail on the different types of digital twins, the elements that make a digital twin, and criteria for digital twins to be used in data-driven maintenance initiatives. After this, I will go into APM Studio to look at a live example of digital twins. And this is followed by a Q&A session, but you can ask your questions at any point in time using the chat function in Webinar Geek, and the moderators will follow up on this. And at the end, I will also answer questions that have been collected over time to the best of my knowledge. Some background. I'm Jules Oudmans presenting to you today. I have a background in AI starting in the 90s, and I've been involved many times in the past 25 years in prognostic and predictive programs that ensure asset integrity for critical assets and critical processes. Here are my contact details. If you have questions after the webinar, don't hesitate to email me. I work at a company called UReason, a software company that provides solutions for real-time condition-based and predictive maintenance. And I help our customers daily to use our software, from data analysis to the setup of applications and solutions that monitor important assets and processes. At UReason, we combine our domain expertise and software knowledge with our customers to help them and guide them from data towards solutions. We have offices in Rotterdam, which we see here in the picture, and in Reading in the UK. And our customers are predominantly in the manufacturing and the process industries, and the majority of them are located in Western Europe and the North Americas. UReason is active in real-time condition monitoring, predictive and prescriptive maintenance, and our field of operation is from helping customers to insights into data, to helping asset owners, OEMs, and maintenance service organizations with data-driven maintenance solutions. Often we start together with our customers to define the business case and use cases to focus on, followed by data collection, model development, and deploying the solutions into the existing OT and IT landscape. Our software, APM Studio, is used at different levels in the automation pyramid. It can run embedded at the lowest level, L0. Often our customers, of course, there are OEMs, where we monitor faults and risks in isolation to the asset. And an asset can be instrumentation, an actuator, a pump, a compressor, a filter, etc. Later on in the demonstrator, I will actually show a digital twin model of a pump running at the lowest level with APM on it and providing its values to a system higher up in the automation hierarchy to do an analysis and provide an efficiency KPI for that pump and a health KPI for that pump. Our software also runs at the edge, processing asset data of one or more assets to run condition monitoring and predictive applications near to where the data is actually generated. And we also work at level 2 and level 3 in the automation pyramid, where APM is used to monitor faults in relationships to the process, running or deployed either on on-premise compute or more and more also on virtualized machines at the premises or in the cloud. When deployed at level 4 and 5, APM Studio is used for optimizing the maintenance costs and planning associated with an asset base supporting a process. Now, in today's webinar, I want to introduce the topic of digital twins. And digital twins get a lot of attention in the media, and I would like to break down in this webinar what a digital twin means and how to apply it in the world of data-driven maintenance. Before we start going deeper into the topic of digital twins, let me ask you a question to better understand where you currently are in your understanding and perhaps also usage of digital twins. So what I will do now is start up an interaction that will pop up below the slides in Webinar Geek. And in that interaction, you can give your feedback. And your feedback is appreciated, of course. So let me know where you are in your understanding, but also maybe using digital twins on your current asset base, current processes. And I'll give it some time for the answers to come in. There's already quite a few answers. The majority of the answers, about 40% of you are investigating the usage of digital twins. And there's a bit of a race going on. The majority now is we're not using digital twins yet. And it's a tie. It's an even set of responses between not using them yet and investigating them. And there's also a group of people, about 20% in the audience, that are already using digital twins. Thanks for your inputs. I mean, if you are investigating it, of course, or if you're using it, we really appreciate if you can provide us some additional details maybe later on. So digital twin technology has actually been around for many years. It's a term that is being used to describe running black or white box simulation models, replicas in a digital format of asset operations or processes. So a digital replica in a software format of a process or a product or a service is a digital twin. So basically it takes real world data about a physical object or a system as inputs and produces outputs in the forms of predictions or simulations of how that physical object or system process will be affected by those inputs. The most common use cases that we see for digital twins are in visualization of products in use by real users in real time, troubleshooting, supporting field teams for remote or inaccessible equipment. Another case is managing complexities and linkage within systems of systems and connecting Disparate systems and promoting traceability, for example, is also a case where digital twins are used to a large extent. Doing, for example, a mass balance over your process is something that you typically don't do in the process automation systems, but in a digital twin supported by a simulation program. Now, there are different types or levels of digital twins, and these have different use cases. We see here in the bottom the component twin. Component twin can be, for example, a bearing twin, a piston twin, or an axle twin. They're typically used to support field services technicians to continuously monitor and offer maintenance, predictive maintenance insights while reducing equipment downtime, planned and unplanned. And component twins enable service-based business models. So they enable OEMs, original equipment manufacturers, for example, to enable service-based business models to provide remote tracking services, remote field services, or triggered field services on the basis of the behavior, potential degradation, potential failure of specific components in assets. Now, the second level or type of digital twin is an asset twin, which could, for example, be an asset twin of a turbine or a motor or a control valve. Like the component twin, they can enable and support service-based business models, but they can also support product management and sales to gather knowledge on customer preferences and actual usage of their product in order to provide new service models and drive revenue. So asset twins are what we enable our OEMs to build, to deploy, and to deliver to their customers. And asset twins can be quite valuable, especially in industries where knowledge and expertise, experience with complex machinery and machinery that is in the bloodline of your processes and systems is slowly ebbing away. Now, the third level of digital twins are the system and unit twins. It's a combination of assets that support a process. So, for example, a crude or reverse osmosis units. It typically helps product engineers, architects, and engineers to improve future product versions and engineering models to optimize product performance and efficiency of the products that they bring to the market. And of course, the fourth level, the process twin, could be a process twin of, for example, an entire composite manufacturing process, helping management to get operational data feeds into production and planning models, and paving the way for strategic insights, recommendations, and roadmaps of future products and product offerings. So there's different types of digital twins, and all these digital twins, of course, are driven by data from either the component, the asset, combination of components, the system, or the process, of course. Now, a digital twin consists of four main elements. Of course, the physical equipment. Here in this case, a motor, centrifugal pump. The twin model, the software model, consisting of a hierarchy of subsystems or subassemblies and components that describe the physical twin and its characteristics, enriched by asset operational, historical, and context data. Knowledge is a very important part of the digital twin model. Data sources that feed the twin with operational settings, domain expertise, industry best practices, etc. And last but not least, analytics, simulation and or machine learning models that can be physics-based models, statistical models, and machine learning AI models to help describe, predict, and prescribe the behavior, the current and the future behavior of the asset, system, or process. Now, in the screenshots, in the slides that I'm showing, various parts of our software, APM Studio, is being used, and we use that very often to set up digital twins for either our OEMs, our OEM customers, or our asset owners. Now, let me ask you another question about the digital twins, of course. And my question is, have you started or do you want to start? So the previous question was about, are you already executing on digital twins or investigating? This question is, have you started or do you want to start? So you may have already started, or you've started and may need assistance, or you've started but don't know where to start best with a digital twin, or you've been overloaded by uh, all kinds of information on the market about digital twins, ranging from documentation twins, which we sometimes encounter as digital twins, to digital twins that require heavy cloud computing, for example. Let me know where you are. So um, at the moment, but by a small lead, the majority of you want to start but don't know where to start yet. We have similar percentage to the previous question as we have not started. No, I have not started with a digital twin program, and a similar percentage, of course, also to I have started. So great. Again, thanks for your inputs. It tells us and learns us a lot about how the market is moving and where it's moving to as well. Now, not all use cases, if you're starting with a digital twin program, not all use cases or business problems can actually be effectively solved by real-time condition-based monitoring or predictive maintenance using a digital twin. Digital twins are not a cure to all illnesses, so to say. The most important qualifying criteria that you should consider during use case qualification for digital twin projects are, of course, an obvious one. Data from the field level can be extracted and enhanced to provide additional insights higher up in the chain. The data and the digital twin must be capable of supporting the business case, meaning that there should be a target or an outcome to predict or calculate that is of value to operations. It's of value to your day-to-day operations. And preferably the problem should have a record of the operational history of the equipment that contains both good and bad outcomes. And just to make clear, you do not need to install or have additional sensors installed to enable digital twins. Very often the data that you already collect, the data that you already have, is of such a tremendous value that on the basis of it, you can already run digital twins. Finally, of course, the business should have domain expertise or experts who have a clear understanding of the problem. And these are the main qualifying criteria for starting with a digital twin project. Now, the steps to realize digital twins are quite logical. I think before you begin, it's not about trying new technology, but selecting a digital twin at the component, at the asset, at the unit, or at the process level that provides value to your organization, to your business, and to your customers, or to your customers if you're an OEM. Value can be reduction of plant maintenance, creating longer preventive maintenance time horizons, or knowing hourly, daily what the risks and associated cost of operation is, etc. So qualify and define, a very important step. The next step is to build and realize a digital twin. What we saw in the previous slides is that you need access to data streams, access to data from your physical assets. Historical data, knowledge, simulation models, and criteria. For example, you want to know where on the PF curve your current asset or fleet of assets actually are. And validation, of course, is key, hence why you need historical data. Once you've successfully validated your digital twin model, you can deploy and embed the digital twin model in your processes. But you do need to monitor its performance, deviations, and embed lifecycle management support of your digital twins into your organization. This is one of the steps, the last step: maintain, update, and improve. The organizational support of embedding this into the organization is where a number of digital twin, a large number of digital twin projects actually fail. Technology is there, has been there for many, many decades. Selecting the business case is of course dependent on where the value is for you or for your customers. Building and validating is something that has been done many, many times. But if you do not embed it well into the organization, update and improve it, it's a single shot digital twin that may over time lose its value. And really try to prevent this from happening. I really recommend that you embed it well into the organization. So we will have a look at how we can set up a digital twin in APM Studio and create digital copies that can be run at different levels in your automation or cloud infrastructure. But before I start sharing my other screen, let me first give you an overview of what we will look at in the live demo. So in the live demo, and hopefully you can see my mouse here, I got a confirmation you can. In the live demo, I have a number of devices, 3 devices, motors that provide only a speed and a frequency. These devices, so there is APM Studio is running on the device. I'll actually be showing a simulation, but the simulation is identical to the field deployment. In the device, APM Studio is running, and it's transmitting over an OI4, Open Industry 4 interface via MQTT, or using MQTT as the transport protocol, its data to an edge computer. And in the edge computer, the data coming from the pump together with the pump performance profiles, pump curves of the pump, and the expected efficiency of the pump is being calculated by APM Studio. And analytics are being performed on the performance of the pump, and there are northbound, so northbound means up, of course, northbound interfaces going towards cloud systems. So the demo I'm showing is a digital copy running of a pump, having only speed and frequency available, transport over, in this case, MQTT using an OI4 compliant message protocol to edge computers that do calculations and analytics on the basis of the data that is received from the pump, and mixing in the data of the pumps with other data that is available from other places in the system hierarchy. So let me switch now to the demo screen. So what I will do is I will move up a screen in here. This sometimes goes wrong because it doesn't attach it. There we go. Nicely. So what we're looking at, and I'll zoom in a little bit. What we're looking at here is APM Studio. So APM Studio is an environment for defining links to data sources, defining how the data from those data sources should be processed, how data from the data sources should be analyzed. We use a technique for this called bow ties, and how the analysis results should be communicated either to external systems or directly to the end users. But we also provide a dashboarding environment inside APM Studio to visualize results and to share results directly with field personnel, for example, on ruggedized tablets or phones, etc. Now, this is one of, as you may have noticed, I've got 4 instances running here. They're all running on my local machine, so it's the identical setup as the digital twin setup has in the field. But of course, doing this webinar, I don't have access to the field. So the field system is actually the Flow Center of Excellence in the town of Dordrecht here in the Netherlands, which is a calibration circuit where process equipment, centrifugal pumps, pressure transmitters, temperature transmitters, flow transmitters, etc., are all connected to a hybrid DCS, and APM Studio is also running there, providing analytics. Now, let's have a look at one of these instances here. And you may have noticed that I've got 3, so they're all lined up after each other. Each of these instances provides data for a pump. We can see that there's data coming in. The instance is quite empty. We have pump data coming in, we have speed coming in, and the operating frequency of the pump coming in. And it's been coming in for a longer period of time. And this instance, local to the pump, has been configured to communicate using a digital twin broker to northbound system. So in this case, our northbound system is an edge computer, and the edge computer does a number of the analytics, a number of the data processing, local, at a higher level in the automation pyramid. Why at a high level in the automation pyramid? Because it can interface to multiple devices in that case. Plus, on an edge level or in edge computing, you typically have more processing power available. So embedded on a chip or on a board in a centrifugal pump or in a control valve, etc., you typically have minimal CPU and memory resources. So that's also the reason why this digital twin is quite empty. It brokers its information to a node higher up in the chain, higher up in the hierarchy, and by brokering that information, a higher level node with more compute and resource power can actually process it, do the analytics, etc. So it's a very nice way of unlocking data from a lower level without actually having to do any programming. So apart from the pump class, and the data feeds, this APM Studio is empty. There's no logic defined in it whatsoever, as you can see here, me clicking away. Now, at the high level, I have a somewhat more complete model. So let me first have a look at the model here. So we have in our model, we have 3 pumps, pump 101, 102, and 103. And we have a different remote model digital twin, which is actually connecting to the other 3, the 3 pump instances, to collect, receive, and process the information inbound from those devices. And if we're going to have a look here at the configuration, it's a client. So this is a client of the digital twin remote assets. It doesn't broker. So this is an edge device that provides the capability at the edge, but doesn't broker going northbound. But it could. It could. There's no limits to this. Now let me open a different window here. Just give me a second. So I'm dragging it up here. This is the MQTT Explorer, an open source explorer to investigate what the MQTT topics are going over the network. This is my local machine. There's a broker running on that local machine, and the broker has received from an application, from UReason, from an APM application, an OT connector. OT connector is something that has been defined by the Open Industry 4 Alliance. And in this OT connector, from the moment that I started it, you can see for 3 instances, D1, 2, and 3, a topic and different messages being published. And the messages that are being published contain the data that needs to be conveyed to the northbound digital twin instance for it to do its processing with. So what we have, going back to the architecture picture for a second there, what we have is these 3 APM Studio applications that are running on the assets, only doing data collection. There is transport over MQTT using the OI4 OEC publication towards an edge compute that does the calculations, the analytics, and the northbound interfaces. And this is in essence, it's as simple as this. This is in essence a digital twin model that keeps a constant track of the health status of the assets, which keeps constant track of data, but can also enrich the external data with additional data feeds, additional data streams. And here we are at a moment in time where the pumps are not switched on. You can see there's a small deviation here in the net positive suction head, but there are in this APM Studio, which is at the highest level above the MQTT Explorer, multiple models, multiple software models that are processing the data from the lower level assets and providing the processing of the data of the lower level assets with different calculations. Calculations to do net positive suction head, calculations to do a calculation of the dynamic head. But there is also, in addition to that, in relation to the total system, analytical models running, which this one was switched off, but analytical models running that provide an input on certain unwanted events that you want to prevent from happening. With this is actually a bow tie. The unwanted event we see here in yellow, a clogging of the contamination of the system, which is introduced by fouling or contamination of the product streams. Different causes that can lead to this in blue, consequences if you do not take appropriate actions, and different tests that will actually verify if this cause contamination or the other cause is currently happening. And these bow tie models are probabilistic models. They use the tests that have been configured in these various blocks in combination with machine learning models, if these are available. So machine learning models you typically train and validate on the basis of historical data of failure or degradation. And if these are available using the palette, you can define new tests. So let's do one here on the fly. A machine learning model. Let's make it a little bit bigger. And inside this block, I can tell the block to trigger on the flow of the main nodes. I can maybe have it wait on certain model updates or wait on certain alarm conditions or states that are currently present. And I can, for example, then add one of these data flow tasks in here to trigger the execution logic to run a PMML, a machine learning model. And these PMML machine learning models are actually fed by PMML model definitions, which is a exchange language for machine learning models. So if you use Python or R or SPSS, SES, etc., and you have analyzed, validated a machine learning model, APM Studio is actually a deployment environment for running those machine learning models online on streaming data. And this can be done at the lower level of also. So it can be done at one of these instance levels where we only have the data. Of course, if the machine learning model has sufficient data inputs, it can be run at this level. But we also need some compute power to give you an impression. A machine learning model with up to 10 outputs and a classification, up to 10 inputs and a classification output, one or two, requires around 20 to 50 kilobytes of memory space to run in within APM Studio. So it's quite high performant, but still you need to have that memory space available at the lower level at your asset in order to deploy that. Okay, so going back to the digital twin models for a second there. Within APM Studio, apart from having to define the transport and the protocol, which could be REST-based, MQTT-based, OI4 compliant, or OpenC UA based, the only thing you have to do on the receiving side in order to accept the data is to define what data you're interested in. So you're interested in a specific type of classes, type of assets. And after you've specified this, you will automatically get your digital twin subscriptions from whichever remote instance connects to it. So the entire infrastructure of connecting, publishing, subscribing to digital twin instances is actually being taken care of in our broker instance. So that's pretty cool, pretty fast also for end customers to implement this as well. Let me go back to my slides and give you a summary slide. So it concluded the demo. I do realize that there may have been a tremendous amount of information in the demo for you. So don't hesitate to contact me if you would like to get a more thorough walkthrough of the demonstrator. I'm always wary of the time that we have for the webinars, and there needs to be some time left also for Q&A. Maybe in the summary slide, let me again reiterate what you can do with digital twins, and the summary slide here is a digital twin of components of assets, components or assets. The example I showed was a process digital twin, but with the digital twin capability, you can very easily extract data from devices in the field, including heart, provides analytics and pre-processing of the data at edge level. That edge level can be an edge computer from Phoenix Contact, from Vago, from Hilscher, etc. Many vendors in this area. And then once you've done the pre-processing, you can do a store and forward using OpenC UA in a data diode type of way. Hence why I use this image here. And in this way, you can provide digital twins at either the on-premise level or in the cloud and connect it to your organizational processes, realizing in effect a NOAA 175 or the Namur open architecture implementation, which is pretty cool. And 5 years ago, if you would ask me, is this possible? I would say yes, with a lot of time and integration effort. Today, we deploy these types of systems in the matter of tens of minutes, I would say. You still have to configure, of course, where the broker instances live and how you would like to deploy, but it's a matter of minutes and not a matter of weeks anymore, which is really cool because it allows you to extract the valuable data that is already there at the field level, for example, hard data or Profinet Profibus data, and have digital twins either running on-premise or in the cloud supporting your work processes. So a tremendous reduction of local inspections, and really going from a reactive mode in maintenance to a mode where you're being steered towards the assets and the components of assets that require attention. Let me ask you one more question. Um, Give me a second to start it. And the question is about your interest in digital twins to monitor your assets. So, are you interested, or would you be interested to learn more about how you can use digital twins to monitor assets and processes? Let me know. It's For us, it's qualifying your answers also to see where the market is moving, how the market is moving. So, just to give you an impression, a year ago, 2 years ago, there was a lot of fuss about digital twins, but people were focusing on getting digital information from the assets and not realizing a twin of the asset, a twin of the asset that provides you with a capability of doing process optimization, asset monitoring, etc. And also because of technology moving forward, standardization efforts moving forward, the focus is more and more now on providing simulation and monitoring twins using either physical simulation models or combinations of physical simulation models with machine learning models to provide assistance and provide support for operations. And at the end of the day, of course, support for the operations is what counts, because that's where most of the times the business value is. Again, thanks for your inputs. With the demo ending, I've actually come almost to the end of the webinar. There is, don't go yet, because we have a Q&A coming up. If you do need to go, please leave us our feedback via the evaluation form. So at the end of the webinar, there will be an evaluation form, but Carlos will also post a link now for the audience that needs to go. So if you need to go, again, thank you for attending. And Carlos will post a link to the evaluation form for people to fill in, and your feedback is really appreciated. I would also like to take the opportunity to promote something that doesn't cost money but does give you a lot of value. Maturity scan. We have put a maturity scan online on our website, and this scan provides you on your organization with an understanding of your maturity towards data-driven maintenance and how you benchmark against the industry and where you can improve. It takes about 10 minutes to fill in. If you have time, 10 minutes time, go to our website. Do the scan, get the free scan is the button, red button on our website. There's no how do you say it, things attached to it. You can just fill it in and you get a maturity scan. We're doing this also to understand and better understand where companies in different regions, in different industries are at and where they're moving to. So 10 minutes and you get a very nice report and understanding back of where you are with respect to data-driven maintenance activities. Now, let me go to the questions. And again, if you need to go, please fill in the evaluation form, and I will switch off the slide. By the way, you will receive the slides and a link to the replay of the webinar as well. I will switch off the slides now and go back to the camera mode. I'm back again. Well, I wasn't gone, but we're not showing the slides anymore. And let's go to the questions. And I just need to find my presenter chat here. And there's quite a few. Let me just take a sip of the coffee. I'm just going down the list. So by Thierry, there was a question. What do you mean telling APM Studio is running on the device to monitor motors on your previous slides? Do you provide your own IoTs with embedded APM firmware? What kind of IoTs? What kind of data can they capture, vibration, temperature, etc.? So we're not a hardware vendor. We provide software, and our software can run embedded on ARM and NXP processors, for example. So we can run on processors that are included by some of the OEMs with their equipment, very near or close to the actual assets where the data is generated, or inside the assets where the data is generated. So Jerry, we can run in the machine. One of the nice use cases of this is a control valve that also has embedded ultrasonic flow meters. APM runs there inside. It's by a company called Focus On. And APM runs inside to do diagnostics, prognostics, and analysis of the data, the high frequency data that is available on the device, and also provides the device with autonomous control possibilities. So we can run inside the device, NXP and ARM chips. If you have cases where there is no data or no sufficient data coming from your asset, we also engage, but we're not a hardware provider. We engage with sensor providers to provide you with solutions and to unlock the data from the lower level systems up to edge compute, and from edge compute up to cloud. And here we work, for example, with Pepperl and Fuchs, with Phoenix Contact, with Hilscher, with again a variety of different companies, with Wago, to realize this. So we don't provide the hardware, but we do provide the support to get data from the lower level. Now, the data that we can capture with APM Studio is very diverse. High frequency vibration data can be captured from IEPE sensors or from MEMS sensors. We do this, for example, with Bluetooth. Lower frequency 4 to 20 milliamp and hard signals can also be captured from flow transmitters, temperature transmitters, pressure transmitters, etc. So we don't provide sensors again, but we do provide the software to work with the various data inputs in different formats and different protocols. I hope that answered that question. It was a very long answer, but you had multiple questions in one. Now is a question from Philippe. On what hardware platforms does APM Studio run? That's funny, Philippe. I'm reading them top down. So we run on ARM and NXP, and of course on let's say the Intel family of processors. And software-wise or operating system-wise, we run on Unix, the industrial Unix variants, and of course on Windows platforms. And then it depends. We run on the Windows Server family, the Windows 10, the Windows 10 IoT. So the latest versions, but also the previous versions of the Windows platforms, of course. Let's see. I'm scrolling down from a question from Christophe. I hope I pronounced it correctly. Does this work with OSI Pi data? Yeah. So OSIsoft, company once founded by Pat Kennedy. It's a long time ago I spoke to him last, but OSI provides a process historian for capturing data from underlying process automation systems, underlying automation architecture. So we can work with OSIsoft with Pi, but also with AspenTech's IP21, Yokogawa's Quantum, Wonderware Historian, PhD from Honeywell. Basically, on the DCS side, we've come across, I think, almost all the historians, but we also work with the new-fashioned or more modern historians, so to say, such as Timescale DB, Influx DB. Let's see, Cassandra, MongoDB as well. So we can work with process historians, the traditional process historians, Pi, IP21X Quantum, Wonder historian. But we can also work with the sometimes NoSQL or time series databases that you see that have been introduced in the last few years. And a question from Kevan, and I think I know who Kevan is even, maybe. I wonder and understood the role of the bow tie in your digital twin model. Is the bow tie required to define barriers and consequences of the digital twin model? If so, can you use, for example, logic tree or fault tree analysis instead? Kevan, it is correct. The bow tie is actually performing on the basis of the streaming data a continuous evaluation of which causes are being activated, leading to potential other consequences. So it's a continuous model, and it is it comparable to a logic tree? Yes, and comparable to fault tree analysis? Also yes. With the small addition is that fault tree analysis is calculating towards a certain unwanted event, and it doesn't evaluate the consequence side. And what we do with the bow ties is that the consequence side is also evaluated, so that gives operations insights as to what to expect or what actions should be taken, and if they're not taking, what consequences to expect. So it gives you a balance between what is happening, probabilistic, so there's an 80% chance of, let's say, a certain unwanted event happening, and it gives you the consequence side of the unwanted event as well, product outage, energy consumption increases, etc. So bow ties were introduced by Shell in the 90s, in the early 90s, and they are actually quite a nice model, representational model of cause, unwanted event, and consequences. And with the cause tests and the barriers, you have a very nice way of representing that back to operations, providing them with an option to evaluate what the potential risks are of the impending degradation or failure. Now there's a question from Lito. How do you justify this digital twin investment to the board? That's a good one, Lito. So digital twins, they don't have to be expensive. Let me start. So investment sounds very big. It doesn't have to be. And justifying to the board is by having a good business case. So if you are going to do digital twins to test the technologies and you have not selected assets or processes or components that if you would improve or provide better insight on them would give you reduce costs, maintenance costs, operational costs, energy costs, etc., or a better insight or reduced risks, then it's not worthwhile. You have to look for the value in investing in digital twins. So, does the investment have to be large? No, because you can base digital twins on the basis of the data that you already have, that you may already be collecting in OSIS of Pi or in OneWare Historian or another historian, other database. So you don't have to make a very large investment for it. And what is also quite nice, in my opinion, in the last few years, the analysis tools have become very powerful. There's also a thing called AutoML, automated machine learning, which enables you to set certain targets, certain criteria that you're interested in, and have the algorithms calculate towards those targets and get the best combination of algorithms with tuning parameters that can then be deployed in, for example, APM Studio. And that would allow you to take data that you already have, train models on energy efficiency or reducing carbon output, etc., and have them work towards that target and provide you with the most optimal algorithm for classifying, detecting, and improving it. Now, the total investment, it is predominantly an investment in adapting new technology. It's not the monetary investment is not big, it's the organizational change. We've always done things in a certain way and reacted on the thing happening. Now, with digital twins from the existing data that you already have at the sites, you can make an organizational change and become proactive instead of reactive. And that's, in my opinion, the biggest barrier. So the investment is not, I mean, if you'd like, Lito, we can work out a business case with you. We do support in that as well from UReason to work out the business cases. There's a question from Jeroen. Is it possible to control or adjust the device when, for example, the analysis shows that in case of the pump, you need to run at a lower maximum speed so that the life will be longer? Yes. The question is, can you do control with APM Studio? Yes, you can. Of course, it depends on the where APM Studio lives in the automation pyramid. So uh, typically it's possible, but you typically don't do control from a cloud instance because the latency that you have, the time latency that you have from cloud to the physical device may be unknown and maybe influenced by systems parameters that you cannot influence, you have no control over. So typically we do control at the edge level, that's above the field device level in control cabinets, in cabinets near to the assets, sometimes a few 100 meters away, sometimes 20 meters away. And you can do control either by triggering control in a PLC, or by doing control inside APM Studio. So we have fuzzy controllers, PID controllers, and various other elements on the palettes of APM Studio to allow you to support this. I skipped the question, so I need to go up one. Do you recommend certain hardware depending on the use cases with pumps? For example, with or without variable speed drives, VFD, variable frequency drives, speed drives, compressors, sensors, etc. Sorry. Yes. So we typically on the basis. So we that was the process in the slides, the business case, use cases, and then we go to build and validate. When we do the business case and the use cases, it will become clear. I mean, we know for the types of assets, etc., what type of hardware you need roughly. But let's say it's a domain, it's an area where on the variable speed drive you need let's say 20 channels at 20 kilohertz or 20 channels at 50 kilohertz extra. In the business and the use case, before going to the build and validate, we'll identify this and also provide recommendations on the type of hardware to be used. And yeah, the hardware does differ per case. So if you are doing monitoring, let's say you have a digital twin that looks only at the heart, the superimposed heart signal on the 420 milliamp, and on the basis of the heart signals plus other data from the process, it provides you with an advisory of steps to take, inspections to do, etc. That's a very low bandwidth IO type application. So you don't need how do you say, an expensive CPU. You don't need expensive processing boards, etc. It's a very low end type application that can maybe be realized with a few €100. If you need to do, or if you're in a more, let's say, fact finding type environment, and you don't know if you need the high frequency data, and you're going to invest in some high frequency ultrasonic or acceleration sensors, yeah, then of course the more IO, the higher sample rate frequency of the IO, the more processing power you need at the other end. And so we typically recommend in this area. And I'm just checking with Arthur is writing. I have another question, sorry, coming in from Lorenzo. In communicating to the cloud, what digital security is enforced? That's a good one, Lorenzo. So I showed an example with MQTT. We don't go with MQTT to the cloud. No, MQTT is for within the site, within the control cabinet, full stop. If we go to the cloud, and maybe I can quickly see if I can jump back here to the slide, and then, yeah. show it. So I'll disappear for a second. This one, share. If we go to the cloud, yeah, you should see my mouse. Just checking. Yeah. If you go to the cloud, we typically have a setup whereby we use an OpenC UA in a setup whereby receiver, sender, and receiver are separately authenticated with separate certificates. And this allows for a very secure data transmission, which is also encrypted. Secure in the sense that it is impossible to understand on both sides what the certificate keys are, and they're mingled. It's called an asymmetric security chain. It's also what, for example, the Bundesamt for Information Technology, so that's the government authority in Germany that looks at information security, recommends as the best practice, and which is also, by the way, I forgot, mentioned in the more open architecture. So in communicating to the cloud, digital security is enforced in having a security setup that is non-symmetrical, with a security protocol that is non-symmetrical. And in addition, if the digital twin application is only providing you with diagnostic information, so from the side we're doing diagnostics up here, and then with, for example, generating a work order, then there is only a push. That's why this diode, data diode figure is in here. It only pushes the data upward in the chain. There's no way to push things down, so to say. So we adhere to industry standards. It's actually one of the webinars that will also be upcoming, if I'm not mistaken, in October, on different digital security practices. But we do not use at this level. Sorry, going up in the chain, we don't use MQTT. It's only at the local level. I hope that answers your question. And let me just switch back. I see, and I think we've come, and there's already some people leaving. Bye, Mark. Bye, Niklas. And by Lito as well, I think, or thank you for the question. I see I've overrun by a minute, but I hope it was valuable to you. Again, after the webinar, an evaluation form will start. It will start automatically. If you can leave us your inputs, really appreciate it. And unfortunately, I have to stop presenting now. So I hope you liked the topic, and maybe in the next session we can go a step further again. And if you have 1 minute, like Carlos just put in the chat, then please leave your comments. Miles, thank you. Jan, also thank you, and hope to see you again next time on the next webinar in 3 weeks on the Thursdays. Guys, take care, stay safe, stay healthy. Bye, Wim. And I will stop the webinar now. Bye bye.